One of the practical advantages of digital systems is their tolerance to noise. Real world signals are affected by interference, attenuation, component imperfections. These sorts of things add noise to the signal. When an analog signal is passed through multiple stages, the noise introduced at each stage becomes part of that waveform. With digital signals, however, each stage can typically interpret the signal using voltage levels and regenerate the signal. This is one of the reasons digital systems are often preferred for reliable transmission and processing. Let's review this by looking at the panels of this graphic. Remember, we've talked about having an analog signal and being able to convert that through sampling and quantization to a digital representation. It's not going to be a perfect copy of the analog signal, but it's really close. If we sample fast enough and we quantize with enough levels, we will essentially get an indistinguishable signal. We're starting with the original signal. As we go through various transmissions and amplifications and different steps, you can see this representation of noise being added along the way. As you add amplification, you also amplify the noise, and you end up with outputs that can be significantly degraded. With digital, we've got this represented as a waveform that represents the binary data that we obtain from sampling and quantizing. For example, this upper level here would be a high voltage representing a 1, then maybe we'd send a negative voltage representing a 0. We can represent with a waveform the zeros and ones that we got from A to D conversion. As we go through and transmit and we get noise added to that signal, it's still an analog signal that's representing digital data at this point. It's still susceptible to noise, but the advantage is that we can tell, oh, this is still a high voltage level. That would be a 1. This is a lower voltage level. That would be a 0. We can have circuits that can go through and clean up the signal as we go, as we process this, and maintain that perfect digital representation of the analog signal.